Hello, my name is Clemens. I'm the CTO of Persival, and today we're going to have a deeper look at how to do animations using standardized formats and standardized interfaces. Namely, we're going to use the ASAM OpenMATERIal 3D standard for the 3D asset and the ASAM OSI standard for the specification of the animations. In my last video, I showed you how to simulate an open scenario file with ESMini, and then look at the OSI trace file, which contains also references to OpenMATERIal 3D assets. And today we're going to have a deeper look into that. So let's start with the Open Simulation Interface specification. I've opened here the sensor view page. That's the top level interface that comes out of ESMini, and that's used a lot of times when you have a scenario player or a simulator connected to a sensor model. And that's the interface to transfer the ground truth data and some other informations from the simulator to a sensor model, for example. So in this, we have the global ground truth, among other data. And in the global ground truth, we have a model reference. And this model reference is exactly the reference to the stationary environment that specified, for example, in an open scenario that's referencing an XOMA file. And then we have the moving objects. So let's go into them. Each individual moving object is defined here with a general definition of the current state, so the position, orientation, velocity, and that's for every single simulation time step. And this, in combination with the model reference, so the model reference not for the stationary environment, but for each individual moving object, gives the possibility to build up the whole 3D environment by placing the objects. That's what I showed in my last video. So in OSI, we get, can actually select that here, we get the position, orientation, and so on of the individual moving objects. And then we have the model reference to an OpenMATERIal 3D asset file. So it's possible to load that. What we have here is the Persival Simspector tool. It's a tool to load ASAM OSI trace files. If you have not seen the video about trace files, check the description below to see that. So a trace file basically just is a binary dump of the data of the simulation. So every time step, every message that was sent in this sensor view is saved here. And what we see now, we can play this back. So you see in every single simulation time step, we have the position and orientation of the moving objects. But in the last video, you probably already noticed the wheels are also moving. So they're rotating and the front wheels follow the steering motion of the car. And I've talked about this in my OpenMATERIal 3D geometry video, that it's enabled in the geometry. So we have the hierarchy in there, and we have the separation of individual parts of that. And we can actually visualize that in Simspector. So we can look at the geometry ID. So you will see the wheels have a different geometry than the body of the vehicle. You have the doors, individual doors have individual geometries. So they're separated in the model, and they have a clear naming convention so they can be identified. So Simspector, as a visualization tool, knows which part of this vehicle belongs to which wheel, front left, rear right, and so on. But of course, it needs the information how to turn the wheel, how to rotate it. And that is all stored also in the OSI trace file. So if we go back to the OSI documentation, you see that we have a field here in the moving object class called vehicleAttributes. And if we go there, we have a bunch of attributes of the vehicle, and we also have wheelData. And the wheelData is a repeated field, so it's basically an array. So for each individual wheel, we have its three-dimensional position, and we have its three-dimensional orientation for every individual time step of the simulation. And that's what Simspector uses here as information to visualize it. It's combined with the OpenMATERIAL 3D definition of the mesh, and we have the information about position and rotation, so we can have that here in the animation. In my OpenMATERIAL geometry video, I not only talked about vehicles, I also talked about other objects like humans. So I brought another trace file. Let me drop that in here. And you see here we have the ego vehicle and we have a pedestrian here. Let's actually jump to the pedestrian. You see the beginning is standing here right at the edge of the road. This is, by the way, the human example from OpenMATERIAL, so freely available. And what we've done now is in OSI, we've defined the skeleton movement. So if you remember from the OpenMATERIAL 3D geometry video, we've talked about that the hierarchy of a pedestrian contains a standardized skeleton. And this skeleton is actually the same as in OSI. So if we go back here from the vehicle attributes back to the moving object, and we have the vehicle attributes that where we looked at before, but we also have pedestrian attributes. And if we go there, you will see a field called skeletonBone. And this is an array of individual bones. And these types of bones are exactly the same as we have in the OpenMATERIAL 3D standard. So you can specify here for each individual bone of a skeleton of a human, its position and its orientation. And that's what we've done here in this example trace file. And now if I play this back, you will see that the pedestrian is crossing the road. And this is not a stored animation in the asset or something that Simspector makes up. This is part of the ground truth data of this trace file. So the single source of truth here is the trace file. Everything's stored in there with references to the OpenMATERIAL data. So you can have quite detailed simulations just using the ASAM OpenX standards. You can move wheels, you can move pedestrians like this, and it's all fully standardized and coherent. So if you have different models connected to one scenario player, every wheel in every model, every pedestrian, every human in every model will have exactly the same motion and the same state in every simulation time step. So this is really great for co-simulation. All right, that's it for this video. In my next video, I will go on a little bit into detail about materials. So we've only talked about geometry, but the standard is called OpenMATERIAL 3D. So we've talked about the 3D part. And in my next video, I will go more into detail to the material side of things. So stay tuned for that. If you have any question, feel free to drop a comment below, and see you next time.